Consider the combustion of methane. Write and balance an equation showing the reaction. All right, well, methane is CH4, okay? So CH4, and then it wants us to undergo combustion. So remember, combustion is when we have a hydrocarbon and we add oxygen and it becomes carbon dioxide and water. Now these two, of course, can be switched. It can be water, carbon dioxide. The order over there doesn't really matter, okay? But we do need to balance this from here. So from this point, I look at the C's. I see I got 1 carbon. I'm okay with that. I look at the hydrogens. I got 4 hydrogens over here, so I need 4 over here. So I've got 2, so we're going to put a 2 in front. So 2 times 2 is 4, so now I got 4 hydrogens. All right, and then here I have 2 oxygens, and here I have 2 oxygens. Right, so I have a total of 4 oxygens, which means I need 4 over here. These are O2s, so therefore I'm going to need 2 O2s so that I have 4 oxygens on each side. You could also think of this as being 1 O2. This is another O2. So I essentially have 2 O2s, right? That's what we got. So there's our balanced equation. Okay, again, I'm going to copy this down over here. We may need that at some later point. I'm also going to put down the first one. The first one was the H2 plus O2 went to 2H2O. All right, because we may need that later. When we do the advanced ones, we'll need that in a little bit. Okay, so those are the 3 that we're doing here. Right now, we're looking at this combustion one. All right, so how many, actually I'm going to go ahead and scroll this up just a little bit, just so that when we get to the end there, we're not writing at the very bottom of the board. Okay, so I can erase this. I just wrote it down right there. Okay. How many moles of carbon dioxide are obtained when 20 moles of methane are completely burned? All right, so the question is about carbon dioxide and methane. Carbon dioxide and methane. And so that's where we're going to look at. We're going to create a mole ratio for carbon dioxide. It looks like I need 1 carbon dioxide. 1 mole. Carbon dioxide compared to methane, which you can see is also 1 mole of CH4. Okay. Now, you can probably figure out, because it's 1 to 1, if I have 20 moles of methane, then I need 20 moles of carbon dioxide. But because I'm trying to teach a process, I'm going to go ahead and write it out. Same thing as before. We know that we have 20 moles of methane. That's the CH4. And we're now going to, multiply this by our conversion fraction factor, okay? And we're going to use this one. We do want the CH4 to cancel out, so we're going to put the CH4 on the bottom. And so we're going to have 1 mole of CO2 divided by 1 mole of CH4. That's my conversion factor right there. And of course, we do see that the mole of CH4 cancels out. And so we go 20 times 1 divided by 1, which gives us, of course, 20 moles of CO2. All right, next one. You're doing so well, right? You're doing great. We're figuring this out. Hopefully by this point, you don't need me to go through the video. Hopefully at this point, you're starting to say, I think maybe I got this, Mr. Bywater. And if that's the case, go try it. Pause the video and try it, work through the next couple, and then you can play the video and see if you got it right. In fact, you could just skip through the video to see if you got it right. And if you didn't, then rewind it and watch this part of the video again. All right, but hopefully you're getting the goal of this is that you can do this on your own, that you can accomplish it without me having to walk you through it. So try it if you haven't yet on your own. Try these next couple, all right? Next one, if only 15 moles of oxygen are available, how many moles of methane can be burned? Okay, so again, here's our connection. We're looking at oxygen and we're looking at methane. So if I look at my balanced equation there, I can see that if I have 2 moles of oxygen, then I can react 1 mole of CH4. All right? So now we go equals, not equals. We're now going to actually do the problem. We have 15 moles of oxygen, so 15 moles of O2. We're going to multiply by our conversion factor. We do want the O2 to cancel out, and so therefore when I use my mole ratio, I'm going to put the O2, the oxygen, on the bottom of the fraction so that it'll cancel out with this. And so I'm going to put the 1 mole of CH4 right there. I'm going to put the 2 moles of O2 right there. And of course, then our moles of O2 cancels out. We'll be left with moles of CH4. And so we have 15 times 1, which is 15, divided by 2, which will be 7.5 moles of CH4. That's the answer. All right? Hopefully that's what you got. Hopefully you're working ahead of me now. You're getting a little bit faster. All right? Let's look at the last one. During combustion, 12 moles of carbon dioxide were formed. How many moles of water were formed? Okay, so this is the first time that we're looking at one where we're actually just looking at the 2 products. Wow, what do I do? You do the same thing. Don't worry about it, right? So the mole ratio, we're still looking at carbon dioxide, and we're looking at water. So write a mole ratio for carbon dioxide and water. I can see right here, 1 carbon dioxide, 2 waters. It's the same thing. So 1 mole CO2 over 2 moles H2O. That's the ratio. Okay? It doesn't matter if you're working with reactants or products or a mixture of those. It doesn't matter. The ratios will still come from your equation. All right? So now we're going to look at the problem. The problem says we start with 12 moles of CO2. Now we're going to use our conversion fraction. We're going to multiply by that. Now again, I want the moles of CO2 to cancel out, so I do need the moles of CO2 on the bottom, so I'm going to rewrite it in that way. So I'm going to put the 1 mole of CO2 on the bottom, and I'm going to put the 2 moles of H2O up on the top. We see that the moles of CO2, good job, cancel out, yes! And then we're left with the H2O, so I just 12 times 2 is 24. So 24 moles of H2O. And we're done.